If you look at the first question, it says the density of copper is 8.83 gram per centimeter cube, and you have to express that in kg per meter cube. So 8.83 multiplied by 1000, you will get 8830 kg per meter cube. So that will be the answer. Now in the second question, relative density of mercury is given. So RD of mercury is 13.6. So therefore, the density in CGS unit, we have just done this, is 13.6 gram per centimeter cube, and density in SI will be 13.6 into 1000 kg per meter cube. Density of iron is 7.8 into 1000 kg per meter cube. Therefore, it will be 7.8 into 1000 gram per centimeter cube. So therefore, density will be 7.8 gram per centimeter cube. And they want the relative density. So therefore, relative density of iron is 7.8. Right. Then the fourth one, relative density of silver is given. So RD of silver is 10.8. Therefore, density will be 10.8 gram per centimeter cube, and that will be 10.8 into 1000 kg per meter cube. Volume is given to be 2 meter cube, and relative density is given to be 0.52. Now, when relative density is 0.52, density will be 0.52 gram per centimeter cube, and therefore the density will be 0.52 into 1000 kg per meter cube. So that will be 520 kg per meter cube. That will be the density. Now we know density is mass upon volume. So this is 520 and volume is 2. So this is 520 into 2, and that will be 1040 kilogram. The mass of air in the room you have to calculate. Now volume of the room will be 4.5 into 3.5 into 2.5. And they have given the density as 1.3 kg per meter cube. Again, density is mass upon volume. So mass is density into volume. So this is 1.3. So this is 4.5 into 3.5 into 2.5. 39.375 into 1.3. 51.1875. So mass is 51.19 kilograms. Mass is given to be 113 grams. And when that thing is immersed in a cylinder, the volume goes from 30 ml to 40 ml. So therefore, volume is 40 minus 30, that is 10 ml. Okay. So you know that for water, 1 ml is 1 centimeter cube of water. And therefore, volume is 10 centimeter cube. Density is mass upon volume is 113 upon 10. So this will be 11.3 gram per centimeter cube. That will be the density. And if you want to find the relative density, so relative density will be 11.3. Okay. So it is the CGS value without unit. That is relative density. Volume is given 100 centimeter cube. Weight in air is given to be 1 kgf. So therefore mass will be 1 kilogram. That will be 1000 grams. Density is mass upon volume. So that is 1000 gram upon 100 centimeter cube. So density is 10 gram per centimeter cube. Therefore relative density is 10. Now they are asking for weight in water. So buoyant force we have studied is VDG. So that is volume. Now volume is 100 centimeter cube. Okay, students. So again, I'm doing like a short revision. 1 centimeter is 10 to the power minus 2 meter. 1 centimeter squared is 10 to the power minus 4 meter squared, and 1 centimeter cube is 10 to the power minus 6 meter cube. So therefore, 100 centimeter cube will be 100 into 10 to the power minus 6 meter cube. That will be 10 to the power minus 4 meter cube. So volume, I am writing 10 to the power minus 4. What about density? This is water, so that is 1000 and G. So that will be 0.1 kgf will be the buoyant force. And therefore weight in water is weight in air minus the buoyant force. That will be 1 kgf minus 0.1. That will be 0.9 kilogram force will be the weight in water. Mass of the body is 70 kilogram. And when it is completely submerged, it displaces water as 20,000 centimeter cube. So therefore, volume of the body is 20,000 centimeter cube. Now, if you want to express it in meter cube, so this is 2 into 10 to the power 4, and meter cube is minus 6. So therefore, you will get 2 into 10 to the power minus 2 meter cube as the volume. Then they are asking us for the weight of the body. So mass is 70 kilogram. So therefore, weight in air is 70 kilogram force. Then relative density. So for relative density, first we have to calculate the density. That is mass upon volume, 2 into 10 to the power minus 2. So here you have 35 into 10 to the power 2. So this can be written as 3.5 into 10 to the power 3. This will be kg per meter cube. And therefore, this is 3.5 gram per centimeter cube. And so relative density is just 3.5. So remember, if you want to find relative density, you have to convert it into gram per centimeter cube and just take the number. Weight in air is given, that is 120 gram force. Weight in water is also provided. I'll take this as WL as 105 gram force. And they are asking for the relative density. So students, today we have done this formula for relative density of solid is weight in air upon weight in air minus weight in water. So that will be 120 upon 120 minus 105. So this will be 15 and 15 8s are. So relative density will be 8. So that's a direct formula. Weight in air is 32 gram force. Weight in water is 28.8 gram force. So they're asking us for the volume of liquid. So following things are asked: volume, then relative density, and the third thing is how much will it weigh in a liquid. So if you call this as water as WL, and they have given the density of the liquid also as 0.9 gram per centimeter cube. Fine. So let us find the volume first. We know that weight inside water will be weight in air minus the upthrust. So therefore here you have 28.8 and this is 32 and that is the upthrust. So upthrust is 32 minus 28.8 and this will give you how much? 3.2 gram per gram force. That will be the upthrust. Okay, now how do you calculate upthrust? By another formula, volume into density into gravity. So over here we have 3.2 gram force will be the volume times density. It is 1 because that is water into gravity. So therefore we get volume to be 3.2 centimeter cube. Okay, so we got the first answer 3.2 centimeter cube. Now for the second one. For the second one, we use this formula of relative density is weight in air upon weight in air minus weight in water. So relative density will be 32 upon 32 minus 28.8. So 32 upon 3.2. So relative density will be 10. It has no unit. So that's just 10. Okay, then comes the next one. Now, if the liquid density is 0.9 gram per centimeter cube, so this will relative density will be 0.9. Therefore, Relative density is weight in air minus weight in liquid upon weight in air minus weight in water. So this is another formula, new one that we have studied today. So this is 0.9 and this is 32 minus weight in the liquid upon 32 minus 28.8. So we have 0.9, okay, which can be written as 9 upon 10, and that is 32 minus WL, and this is 3.2. Okay, so what do we get? We get 9 into 3.2 upon 10 is equal to 32 minus WL, 2.88. So WL is 32 minus 2.88, and therefore the weight in the liquid will be 29.12 gram force. So this will be your final answer. Okay, so this is relative density of solid, and this is the formula to find the relative density of a liquid. Question number 12. A body weighs 20 gram force in air. So weight in air is 20 gram force, and weight in water is 18 gram force. So what is the relative density? Relative density is weight in air upon weight in air minus weight in water. So that will be 20 upon 20 minus 18, 20 upon 2, that will be 10, just 10. Relative density is only the number. Okay, question 13. Again, weight in air is given, that is equal to 1.5 kilogram force. Weight inside a liquid is 0.9 kgm. Density of liquid is 1.2 into 10 to the power 3 kg per meter cube. And they are asking for the relative density of the solid. Okay, so how to do that? Now you know that relative density of liquid is weight in air minus weight in liquid upon weight in air minus weight in water. Okay, so this way what we can do is relative density of the liquid is 1.2. You can see that because over here this will be 1.2 gram per centimeter cube, and therefore relative density is 1.2. Weight in air is given to be 1.5. Weight in liquid is equal to be 0.9. And here this is again 1.5 minus weight in water. Okay. Now students, 1.2 is 12 by 10. That is 2 6 are 2 5. So I'm going to write it as 6 upon 5. And this will be 0.5, so that will be 0.6. And this will be 1.5 and weight in water. So this will be 6 multiplied by 1.5 into weight in water. That will be 0.6 into 5. So 1.5 minus weight in water will be 3 by 6. That will be 0.5. And therefore, weight in water is 1.5 minus 0.5. Weight in water will be 1. Okay, 1 kgm. So what is the relative density of solid? RD of solid is equal to weight in air on weight in air minus weight in water. And that will be 1.5 upon 1.5 minus 1. That will be 1.5 upon 0.5, and that will be 3. So relative density of the solid is 3.